This podcast is brought to you by LMU Munich.
Okay. Hi, everyone. Right now we're starting a talk by Sahil Dua. He's going to talk about processing multidimensional data in Pandas. So.
Hi, I'm going to give you an overview of different mostly used features of this cool library that is Pandas. First of all, something about myself. I'm Sahil Dua. I work at booking.com. Oh, and by the way, just like many other companies, we are hiring as well. We have different teams which work on A/B testing, NLP, recommender systems, machine learning, and all these things. So if you're interested, here's a link, or get in touch with me. I can help you more with that. And if you're still not convinced, it's Amsterdam. So come on. Coming back to myself, I've contributed at Pandas and Linguist, which is a project by GitHub. The project that is in production on GitHub website, which detects what language your repo is. And then I work at DuckDuckGo as an open source community leader. How many of you have used DuckDuckGo? Okay, cool. So if you're in for a little surprise, you can search for this on DuckDuckGo and you can find for yourself what it gives you. So coming to the talk, why do we need Pandas? Python is already great, right? Python is great at fetching data. Python is great if you want to scrap data or munch the data. But it's not that great if we want to analyze the data. We generally tend towards some domain-specific languages like R whenever we have to analyze the data. But what if we can do the same thing in Python as well? So Pandas is there to bridge that gap that we have. So just like we do with all the other, like whenever we're talking about new library or new language, we talk about how can we store our data, what are the data structures that we can use to store our data in memory. So there are some data structures like series. Series is just like a list in our native Python, but it's actually on the background, it's actually a NumPy 1D array which is labeled. So it has row labels which are called indices. It has some values which can be anything, string, character, integer, float, or even boolean, or even none value, not defined value. Next we have DataFrame, which have multiple columns. So there are row labels which are called indices, and there are column labels which are the names of the columns. Again, the data can be anything, of any data type. So let's see how we can create these data structures using the native Python data structures. For series, we can just use the list which is available in the Python, and this is what we will get. So we get the values of the series same as the list that we passed, and by default the indices are 0, 1, 2, and 3. So what if we want to change the index? We can mention that in the constructor itself, and this is what we'll get. Easy, right? Now let's see how we can create DataFrame. Again, we have to use the native Python data structures to make the data structures in Pandas. So again, DataFrame is a 2D NumPy array which is labeled, which has two labels. If we pass a dictionary, this is what we'll get. The keys of the dictionary will be the column labels, and the indices by default will be 0, 1, 2, and 3 again. And if you want to change the index, you can do that again, just like you did with the series. Now let's take this data frame and let's see what we can do with this, how we can manipulate this data, or how we can perform some operations on this. So let's see, first of all, very simple operations which are like, we want to select one column. We want to, for this case, we want to fetch column which has column label foo. We can simply do this. We can pass the name of the column to the square brackets. What do you think will be the data structure that will be returned? Any ideas? Exactly. So it will be a series with the default indices. Now if we want to select the multiple columns, we can do this. Just pass a list of all the column names which you want to fetch, and it will give you those. Again, which data structure? Easy, right? DataFrame, yes. So what if you want to select one row? You can use the location method, which is LOC. You can just pass the index of the row that you want in the square brackets, and it will give you, yes, but with a different index this time, because the index this time will be the column names, because that's how we are going to access the values. And if we want to select multiple rows, we can do this. It's almost like Pythonic way of doing things, and this time we will get a data frame. So this was easy, right? We knew what we want to fetch, but what if we want to select the rows on the basis of some condition? We can, let's say for example, we want to fetch only those rows which have true value for third column. We can do this. We can just mention the condition that we have for our case in the square brackets, and it will give us only those rows which actually satisfy that condition. Now that was easy. Let's consider another case. Let's say we want to fetch all those rows which have either X or Z in their first column. We can again do this. It's as simple as mentioning a condition in square brackets, and the condition can be any type of condition, like any complication or anything can be done. Again, it gives us those rows which satisfy the condition that we mentioned. Now, let's say we have two data frames. One is this, which has indices A, B, C, and D, and column labels A, B, and C. The other one has A, B, C, D, E indices and column labels A and B. What if we decide to merge these? Just like we do join tables in MySQL, we can merge them in Pandas as well. It's called an addition operation, but it's not actually the arithmetical addition. It's like merging two data frames or merging two data structures together. This is what will we get. There will be some not defined values, like we can see in E, all the values are not defined, and in C, all the values are not defined. Other values are sum of the two values in the two data frames. Why the values are not defined? Because we don't have E index in first data frame, so it doesn't know what should I take from the first data frame, and hence it's not, that values are not mergeable. So similar case is with the C column. It's not present in the second data frame, hence all the values are not defined. That is not a number, which is data type for none in NumPy. So since we have a lot of missing values, a lot of not defined values, how can we take care of these values? Because if we want to analyze our data, if we want to do something with our data, we should have some defined data so that we can operate, we can do some operations on it, or we can make some sense out of that data. So whenever there is some non-defined value, what we can do is, like, we have two options. Either we can drop the non-defined values, or we can fill the non-defined values. So we can do both with Pandas. Let's see how. First of all, if we want to drop the non-defined values, you have a simple method which is drop NA, and by default it will drop all the rows which have at least one non-defined value. Simple, right? But you can see in this case we lost these two values, Z and false. What if we want to drop only those values which have all the non-defined values, and if it has at least one defined value, we keep it? You can simply mention how do you want to drop the values. You mention how equal to all, that means you want to drop the values only if all the values are non-defined. And this is the result. Now coming to the second part, which is what if you want to fill in the values. But if you don't want to drop anything, you want to fill in the values, you want to either fill in some default value or interpolate or extrapolate or forward fill or different things. So first thing is the simplest one, which is you mention a default value. You mention what value you want to put in instead of the non-defined values. And as simple as that. It gives you a new data frame which has all the values defined. Now, what if you want to forward fill? What forward fill means is it will look for the defined values before the undefined value and copy that value into the non-defined values. So to see the example, we use the method ffill, which means forward fill, and as we can see, this value is not defined, but here it's equal to z, which is the last value that is defined. The similar case with this one, it will copy 10 into both the values, and similar is the case for the third column as well. Now, what if you don't really want to copy all the values, you just want to copy, like let's say one value? You can limit the number of copies that your operation will make. So in this case, you will get this, which means only once this 10 is copied, but not for the second time. Now coming to the most important and some like the USP of this library, which is indexing. As I talked about it, we have different types of indices. We have we can by default have a range index, which is 0, 1 to 3, and we have something customized index, which you can set by defining it into the constructor. So if we want to fetch the index, we can simply do this and we will get a range, which is 0 to 3. Now, what if we want to change the index? In this case, we have a default index, which is 0, 1, 2, and 3. And if we have some particular column which we want to make index, we can simply do this. We can mention the name of the index and pass it to set index. It will give us this. The new data frame will have only 2 columns, and the column that we mentioned will now be an index. Now let's see how we can perform different operations which we performed earlier on this new data frame. If we want to fetch the row, we know the index, we pass it to lock method, and we get this. And if we want to still mention the iterator, if you still want to mention that, okay, no, I don't want to mention the index name, I know that it's the first row, I know it's a 0th row, and you can do this. You can use the iterator location method, and it will return you the same thing. Now, another cool thing about Pandas is you can have hierarchical indexing, which is like having multiple level indexing. You can mention all the indices that you want to have for your list and pass it to set index again. This is what you will get. So for this case, we have one level index which is 1 and 2. Then we have another level index which is A, B, C, and D. Now 1 points to A and B and 2 points to C and D. We'll see how we can perform different operations on this. So now if you want to select 2 rows, we can fetch the rows from 1, it will give us this data frame. If we want to fetch only 1 row, we will go from 1 to A, and then we get this. Just mention 1 and A, you will get it. Just like many other operations, we have this simple operation to find to easily find the transpose of the data. So if you just do .t, it will give you this new data structure. Now, coming to the another aspect of this library, applications of this library, we have statistics. We can perform different operations using this library. We can do describe, which gives us description of our data. I will be showing that in a demo in a couple of minutes. We can find covariance, we can find correlation, we can find rank of the different values in a column. We can find cumulative sum as well. So let's go to the most difficult part of this talk, the live demo. Is this visible? Good? Yeah. So, do we have any football fans here? No? Yeah, just one, two. Come on. Okay, so I'm going to take a data set which is number of goals scored by Messi and Ronaldo in last 10 years. And I'm going to perform some simple operations on that, and we'll see how easy it is to analyze any data. And this is just a small data set. We can perform the same operations on any large data set as well. So let's start. I have import the library and make the matplotlib to plot the graphs. And now I have this data frame. I have keys, Messi, Ronaldo, and year. Now let's see what our data looks like. It's a data frame, default index 0, 1, 2, 3, and Messi, Ronaldo, and year. So now what we want to do is we want to have an index which is a year, so that we can easily access number of goals scored by any player in that year. What we can do is simply pass set index, and the new index, new data frame that we have is this. As you can see, we have indices years and then number of goals scored by Messi and Ronaldo. Now, what if we want to fetch the number of goals scored by Messi in different years? We can do this. So, selecting a particular column is covered. What if we want to find the number of goals scored by both the players in a particular year? We can do this. And we have 43 and 40 in 2016. What if we now want to compare these two players and we want to see which player performed better in which years? So let's consider the case let's select the rows which have, in which years Ronaldo performed better than Messi. Yeah. Just mentioning the condition that we have, and it's that easy. Now, if we want to find information about our data, we can see it has data columns, 2 columns, Messi, Ronaldo, 10 values, integers, and it just takes 240 bytes. And now if we want to see, just like we see with our MySQL tables, we see select star from this table, limit by this, so that we just want to see what kind of data is there. We can do the same thing. We can mention how many rows do we want to see, just for the sake of seeing it as a sample, and it will give you the rows, whichever you want. And from the end, it will give you via tail. Now coming to the statistics methods, which is, first one is describe. It gives you a bunch of information. So let's talk about it. Count is the number of values that we have. Mean, the number of average goals. We have standard deviation, we have minimum, 25 percentile, 50 percentile, 75 percentile, and the maximum value. Now, if we want to find the covariance, we can find the covariance between these two players' performances. We can find correlation between these two performances. We can see there is not much correlation because, of course, these two players are independent. We can, now comes the interesting part. We want to find which player scored the most goals in last 10 years. Messi. That's what data says. I don't say anything. Don't fight with me like, okay, no, Ronaldo is better or this player is better. That's what the data says. We have 502 and 497. And if we want to find cumulative sum, we have this. Using this, we can see up to 2013, which player had how many goals. It can be useful in your case, and we can have different use cases. Now, coming to the visualization part. Now, analyzing, it's not all about just seeing the data in data frames. You should be able to plot some graphs. You should be able to visualize the data as well. So we can simply use df.plot. Yep. We can see which player did how well which player did in which year, and if we want subplots, we have this. If we want to observe the performance in different graphs. Different kind of graphs, we have area graph. Okay, it is stacked. If you want to make it non-stacked, you can just mention this. Now it's not stacked over each other, it's absolute graph which says which player did how well. And the last thing is bar graph, which exactly tell you in which year, which player performed well, how well, and things like that. That's all about the demo, and thank you. That's all about my talk, and you can get in touch with me if you have any doubt, or I will be in the hall. And also, I have some cool goodies from booking.com, some goggles, some bags, some stickers. So if you want, you can take from...
Yeah, you can come up to me. I will give them out before the lunch. So we have some time for questions. Who would like to start? I don't see any hands.
Everything is clear, right?
Well done.
Okay.
Okay, so if there are no questions, please the next speaker can come up and you can find Sahil
Yep.
using all those usernames. So thank you.
Thank you.